Some trigonometric identities. So what's that all about? Well, maybe you've seen that word game where you change one word into another by changing one letter at a time, each time making a legitimate English word. So for example, to change walk to ride, one way to do it would be change the W to a T to get talk, K to E, tail, A to I, tile, L to D, tide, and then T to R, ride. You want to try another one? Try changing wet to dry. If you want to do it yourself, pause the video and then come back and I'll show you my solution. Okay, here's one way to do it. Change wet to bet to bat to bay to day, and day to dry. So verifying trigonometric identities is a little like that. You're changing one thing to another, one step at a time. Here's an example of a trigonometric identity. Tan x sine x equals secant x cosine x. So that means that the tangent of x times the sine of x is equal to the secant of x times the cosine of x for any x for which those are defined. Those are not equal just for some particular x, they're equal in general. That's an identity. But to prove that they're equal, to show or verify that those two things are always going to be the same as one another, we have to start with one of them and change it into the other, one step at a time. Here's one way of doing that. We can start with tan x sine x, and then tangent is equal to sine over cosine. So we can make that replacement. And then we can multiply those two sines together and write it as sine squared of x over cosine of x. And then we have that Pythagorean identity that says that sine squared plus cosine squared is equal to 1. So that means we can replace sine squared with 1 minus cosine squared because they're always equal. So now it's 1 minus cosine squared of x over x. Then we can break that fraction up into two separate fractions. 1 over the cosine of x minus cosine squared of x over cosine x. And then 1 over cosine x is equivalent to the secant of x. And cosine squared of x over cosine x, well, you divide out the cosine x and you're left with one of the cosines. Cosine times cosine divided by cosine is cosine. So we end up with secant x minus cosine x. So the two expressions are equivalent to one another because each step is equal to the step after it. So to verify an identity, the general procedure is start with one side. It can be the left side or it can be the right side, whichever way you want to start, and then step by step transform it into the other side, where each step you're using either one of those fundamental trigonometric identities or some legal algebraic maneuver. The fundamental trigonometric identities that you should remember and have at your fingertips to use are the reciprocal identities. Remember which trigonometric functions are the reciprocals of each other. The quotient identities, remember that tangent is equal to sine over cosine and that cotangent is equal to cosine over sine. And the Pythagorean identities that let you relate the squares of certain trigonometric functions. So now for some examples. Tangent theta over cosecant theta equals sine theta over tangent theta. Okay, we'll start with tangent theta over cosecant theta. And our goal also has a tangent theta, so we don't really have to change that part. But we have to do something with the cosecant. And one thing about cosecant is it's equivalent to 1 over sine. So I can write it that way, tangent of theta over 1 over sine theta. But dividing by a fraction is the same as multiplying by the reciprocal. So now it's tangent of theta times sine of theta over 1, or just sine of theta. And since multiplication is commutative, it doesn't matter what order those two are in, I can switch them around and say it's sine of theta times the tangent of theta, and we're done. Okay, that was a pretty easy one. Now, how about this one? Tangent squared of theta over secant theta minus 1 equals 1 plus secant of theta. Now, on all of these, you're welcome to try to pause the video and figure it out for yourself before I show you the answer. On this one, because this involves tangent squared, that makes me think of maybe using one of these Pythagorean identities. The tangent squared would be equal to the secant squared minus 1. So that might be a good first step. Start with this. Tangent squared theta over secant theta minus 1, and transform tangent squared into secant squared minus 1. Okay, what now? Well, secant squared minus 1 can be factored because it's a difference of two squares. You got secant squared minus, you can think of this as 1 squared. So we can factor that into the secant of theta minus 1 times the secant of theta plus 1. And now notice we have a secant theta plus 1. Well, that's what we wanted. And then we have a secant theta minus 1 on top and on the bottom that we can cancel or divide out. So when we do that, we are left with 1 plus secant theta. The end. Okay, how about this one? Cotangent theta over secant theta equals cosecant theta minus sine theta. Okay, cotangent theta over secant theta. What can we do with these? Well, the cotangent is equal to the cosine over the sine, and the secant is equal to 1 over cosine. Does that help us? Well, now we've got this big multi-layer fraction. Let's treat it as a fraction divided by another fraction and turn it into the top fraction times the reciprocal of the bottom fraction. Cosine theta over sine theta times cosine theta over 1. Now, if we multiply that together, we get cosine theta times cosine theta. That would be the cosine of theta squared. And of course, sine theta times 1 would just be sine of theta. Aha, cosine squared. That makes me think of those Pythagorean identities. What is cosine squared equivalent to? 1 minus sine squared. So now we got 1 minus sine squared theta over sine theta. Now let's break this up into two separate fractions. 1 over sine theta minus sine squared theta over sine theta. And I think you can see what's coming next. 1 over sine theta is the cosecant of theta. And then the sine of theta squared divided by the sine of theta just to the first power leaves us with 1 sine theta left. So we end up with cosecant theta minus sine theta. Okay, how about this one? 1 over 1 plus sine x plus 1 over 1 minus sine x equals 2 secant squared x. Okay, let's start with the left. Looks a little more complicated, and maybe it's better to start with the side that looks more complicated because that gives you more things to grab onto or things to work with. Okay, we have these two fractions that if I wanted to add them together, to add fractions, you need a common denominator. So let me get these to have the same denominator as each other by multiplying the first fraction by 1 minus sine x on top and on the bottom, and multiplying the second fraction by 1 plus sine x on top and on the bottom. And now that they have the same denominator, we can combine them into 1 minus sine x plus 1 plus sine x all over. Now, I went ahead and multiplied that out on the bottom. The denominator multiplied out is 1 minus the sine of x squared. And then on top, this simplifies to 2. The 1 plus 1 is 2, and the minus sine x plus sine x add up to 0. So it's 2 over 1 minus sine squared x. But 1 minus sine squared is equivalent to cosine squared. So I can write this as 2 over cosine squared x. That's that Pythagorean identity there. And then a cosine squared on the bottom is equivalent to secant squared, because remember, 1 over cosine, the reciprocal of cosine, is secant. And here we just have that squared. So we end up with 2 times the reciprocal of cosine squared is secant squared of x. How about this one? 1 minus sine x over 1 plus sine x equals tangent of x minus secant x squared. Now let's see, we might start with the right side and multiply that out. Take that tan x minus secant x squared and multiply it out, and we get the first thing squared minus 2 times the first thing times the second thing plus the second thing squared. And I'm not really sure where to go from there. We might be able to do something with this, like turning tangent into sine over cosine and secant as 1 over cosine, and we might be able to get somewhere like that. But let's go back and see what we can do with the left side. Okay, so if we start with this, I'm going to multiply the top and the bottom by 1 minus sine x. And the reason I'm doing this is because if you remember that last example we did, where we had a 1 minus sine squared and that turned into cosine squared, I think I want that to happen here. So I'm going to take this 1 plus sine x and multiply it by 1 minus sine x, because when I multiply those together, I get 1 minus sine of x squared. Meanwhile, on top, when I multiply that out, I get 1 minus 2 sine x plus sine squared x. Okay, so like I said, the 1 minus sine squared can turn into cosine squared. So now it's 1 minus 2 sine x plus sine squared x over cosine squared x. Now let me separate this out into the individual fractions. 1 over cosine squared x minus 2 sine x over cosine squared x plus sine squared x over cosine squared x. So 1 over cosine squared, that would be the same as 1 over cosine squared. This I'm going to separate out into a 2 times a sine over cosine times a 1 over a cosine. And then this I can think of as a sine over a cosine and then the whole thing squared. Okay, so this is where we are right now. So now 1 over cosine is secant, and that's being squared. We've got 2 times sine over cosine is equivalent to tangent, and 1 over cosine is equivalent to secant. And then sine over cosine is tangent, so we got that squared. And then does this look familiar? Well, it's not exactly what we saw when we multiplied this out, because it had tan squared at the beginning and sec squared at the end, but they're both positive. We can switch the order around, write it as tangent squared x minus 2 tangent x secant x plus secant squared x. And then that sort of factors into tangent of x minus secant of x squared. Okay, that one got a little complicated, but we did it. Now, I don't want this video to run too long, so I'm going to do my next example in part 2. So there will be another video with the next example.